Good morning, everybody. Hope you're doing great wherever you're watching from. So there is breaking news right now, and it's not coming from a war zone or a border dispute. It's coming from underneath the ocean. Right now, in the middle of the Pacific, water temperatures have crossed a threshold that only happens a handful of times in a century. And what happens next is going to touch almost everything you deal with in the next 12 months. Your electricity bill, your grocery bill, your travel plans, your insurance premiums, and if you live anywhere near a coastline, possibly your safety. We're talking about a Super El Niño, and as of the last several weeks, it is no longer a maybe. It is here, it is intensifying faster than almost any event scientists have on record, and multiple agencies are now saying it could become the strongest El Niño ever measured. So today we're going to break down exactly what's happening in that ocean, why it's moving this fast, what it's already doing to weather patterns across the country and around the world, and what the next 6 months look like if the current trajectory holds. We'll get into the mechanics of how a patch of warm water thousands of miles away in the equatorial Pacific ends up deciding whether your winter is brutal or mild, whether hurricane season stays quiet or turns violent, and why farmers, insurance companies, and energy traders are all watching the exact same numbers right now with a lot more nervousness than usual. And stick around toward the end, because we're also going to connect this to something most weather coverage completely ignores, which is what this actually means for food prices and household budgets over the coming year. So stick around, because by the end of this, you're going to understand this shift better than most people talking about it on the news. Let's start with where this actually stands right now, because the numbers themselves tell a story. Back in the spring, forecasters were cautiously talking about a possible moderate El Niño developing later in the year. That's a normal semi-frequent event. It happens every 3 to 4 years and usually causes some noticeable but manageable shifts in weather. Nothing that would make headlines outside of specialized forecasting circles. But then something changed. By June, ocean temperatures in the benchmark monitoring zone had already warmed to about 4 degrees Celsius above average, up sharply from just 7 degrees only a couple weeks earlier. In oceanography terms, that's not a gradual drift. That's what scientists call rapid intensification. Water doesn't usually heat up that fast across a region that spans thousands of miles of open ocean. There's an enormous amount of thermal mass involved, so when you see numbers jump like that in such a short window, it tells you the underlying atmospheric and oceanic feedback loops are reinforcing each other rather than fighting one another. By the time we got into late July, that number had climbed even further, and it had already blown past the 2-degree mark that formally defines what's called a Super El Niño. To put it plainly, we are no longer asking if this event qualifies as historically strong. It already does. The question now is how much stronger it gets before it peaks, and every major forecasting body is leaning toward the answer being a lot stronger. The Climate Prediction Center put out an update in July saying El Niño is expected to keep intensifying all the way through the end of the year, with a 97% chance it persists into early spring of next year, and an 81% chance that it reaches what's classified as a very strong event during the October through December window. That would place it among the largest El Niño events in the entire historical record, and that record goes all the way back to 1950. Then AccuWeather came out with their own number in early August, putting the odds of this becoming an officially designated Super El Niño by the end of hurricane season at more than 90%. And if you want a sense of how seriously the financial and trading world is taking this, prediction markets are pricing in an 88% chance that winter will see a full-blown Super El Niño locked in. When you've got government climate scientists, private forecasting companies, and people literally betting real money on outcomes all pointing the same direction, that's not noise, that's convergence. And convergence like that doesn't happen very often in long-range forecasting. Usually you'll see disagreement between agencies, different models pulling in slightly different directions, hedge language everywhere. Right now, almost nobody credible is pushing back on the trajectory. The disagreement isn't about whether this becomes historic, it's about exactly how historic. Now, before we go further, let's actually explain what El Niño is, because a lot of people hear this term thrown around every few years and nod along without really understanding the mechanism underneath it. And once you understand the mechanism, everything else about this story makes a lot more sense. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific Ocean. Think of it as a conveyor belt of air moving warm surface water from the coast of South America toward Asia and Australia. As that warm water piles up in the western Pacific, cooler water rises up from the depths off the coast of Peru and Ecuador to replace it. That cold upwelling is actually really important. It feeds nutrient-rich water that supports massive fish populations. Off South America, entire fishing economies are built around that cold water cycle, and it also keeps the atmosphere in a certain kind of balance. This whole system of rising and sinking air across the tropical Pacific is called the Walker circulation, or the Walker cell if you want the technical name, and it acts almost like a pressure valve for the entire planet's weather engine. Warm, moist air rises over the western Pacific near Indonesia, travels high in the atmosphere back toward South America, sinks as dry air over the eastern Pacific, and then the trade winds at the surface carry it back west again to complete the loop. El Niño happens when those trade winds weaken or even reverse. Instead of warm water getting pushed and held in the western Pacific, it slides back toward the central and eastern Pacific and just sits there, spread out over an enormous area of ocean. When that shift happens, the entire Walker circulation essentially breaks down and reorganizes itself around the new location of that warm water. That warm water releases heat and moisture into the atmosphere above it, and because the atmosphere doesn't like being out of balance, that extra heat and moisture gets redistributed globally through shifts in the jet stream, changes in storm tracks, and altered pressure systems that ripple out from the tropics all the way to the poles. That's the entire mechanism in a nutshell. A patch of warmer than usual ocean water in one part of the planet ends up rewriting rainfall and temperature patterns almost everywhere else. It sounds almost too simple to be true, but it's been documented and measured for decades, and it's one of the most reliable large-scale climate signals we have. Reliable enough that entire industries plan around it a year or more in advance. Now here's where it gets specific to what's happening right now. Scientists classify these events on a sliding scale. A weak El Niño is anything above about half a degree Celsius warmer than average in that Niño 3. 4 monitoring zone, which is essentially an invisible box drawn across a stretch of the central and eastern Pacific that agencies use as the standard measuring stick, sitting basically along the equator between roughly 120 and 170 degrees west longitude. A moderate event crosses 1 degree, a strong event crosses 1.5 degrees, and a Super El Niño, the rare top-tier classification, requires ocean temperatures to be sustained at 2 full degrees Celsius above average or higher for a period of about 3 consecutive months. We are already sitting above that 2-degree threshold, and multiple ensemble models, including runs from the European Center for Medium-Range Weather Forecasting, are now showing this event potentially pushing beyond 3 degrees above average by the time it peaks later this year. If that verifies, we are talking about one of maybe 6 or 7 events in the entire past century and a half that would qualify at that intensity, and it would be sitting right near the very top of that short list. Let's put that in historical context, because numbers on a chart don't mean much until you compare them to something real. Intense El Niños like this are genuinely rare. Since 1950, there have only been 5 events that reached true super status. The most recent one was back in 2015 into 2016, about 11 years ago. That event brought severe coral bleaching across huge stretches of ocean reef systems, catastrophic flooding in parts of South America, and one of the warmest years on record globally at the time. Before that, you have to go back to 1997 and 1998, which is still widely considered the benchmark for comparison by most climate scientists because of how extreme and far-reaching its impacts were. Before that, events occurred in 1991 to 1992 and 1982 to 1983. Which actually caught forecasters somewhat off guard at the time because monitoring technology wasn't nearly as advanced as it is today, and the event was well underway before anyone fully grasped its scale. If you go even further back into the historical record, there's documentation of similar intensity events happening in the late 1800s in 1888 and 1877, based on reconstructed climate data. So when forecasters say this current event could rival or even exceed 1997, that's not a throwaway line meant to grab headlines. That's them telling you this could be a once-in-a-generation event, something most people watching this video have maybe experienced once or twice in their entire lifetime, if that. So what actually happens when an event like this peaks? Let's start with the most immediate and dangerous piece, which is hurricane season, because we're right in the middle of it right now. This is actually a case where a stronger El Niño produces an effect that sounds counterintuitive at first. You'd think warmer oceans would mean more storms, right? More heat, more fuel, more hurricanes. But that's not how it plays out in the Atlantic Basin specifically, and here's why. A strong El Niño increases wind shear across the tropical Atlantic. Wind shear is essentially a difference in wind speed or direction at different altitudes, and hurricanes hate that. They need a stable, consistent atmospheric column to organize and intensify, almost like trying to stack a tower of blocks while someone keeps pushing on it from different angles at different heights. When you introduce strong shear into the mix, storms get tilted, torn apart, or prevented from ever fully organizing in the first place. That's exactly what's been happening. Major forecasting groups, including Colorado State University's well-respected seasonal outlook team, have already been walking back their hurricane season predictions, reducing the expected number of named storms and hurricanes, specifically because of how fast this El Niño has been ramping up. Systems that would normally have a clean shot at strengthening are instead getting shredded by upper-level winds before they can become serious threats. We've already watched this happen in real time this season, with storms that looked promising on satellite getting torn apart within days as they ran into hostile upper atmosphere conditions. Now, that doesn't mean hurricane season becomes a non-issue. It means fewer storms, but it doesn't guarantee those storms are weak. It also shifts steering currents, meaning the paths that storms take can be different than what you'd expect in a normal or La Nina year. So, less frequent, but the ones that do form can behave unpredictably in terms of where they end up making landfall. And history has shown that even in quiet El Niño hurricane seasons, you can still get one or two storms that defy the odds and become major landfalling systems. Meanwhile, on the Pacific side of the world, it's almost the exact opposite story. El Niño tends to fuel more activity in the eastern and central Pacific basins, because that's literally where all the extra warm water and atmospheric energy is concentrated. So, while the Atlantic quiets down, forecasters are already watching increased activity levels build up across the Pacific, which matters a lot for Hawaii, Mexico's Pacific coast, and parts of Asia that don't normally see this much tropical activity in a given season. Let's zoom into what's happening domestically right now, because this event is already actively shaping the forecast for the rest of the summer. The pattern splitting the country right now is almost a textbook signature of how a strengthening El Niño starts to assert itself before it even fully peaks. Much of the central United States, the plains, and the Midwest is looking at a stretch of below-average rainfall paired with dangerous, prolonged heat. That's a direct function of high-pressure building and holding in place over that region, acting like a lid that traps heat and blocks storm systems from breaking through, sometimes for weeks at a time. That kind of persistent ridge is exactly the setup that turns a normal hot summer stretch into the kind of extended heat event that stresses power grids and puts agricultural yields at risk. Meanwhile, the Northeast, the Great Lakes, and the Ohio Valley are looking at one of the most active stormy patterns in recent memory, with frequent cold fronts and repeated rounds of precipitation keeping temperatures below normal and rainfall totals climbing well above what's typical for this time of year. That's not a coincidence. That's the atmosphere redistributing energy exactly the way you'd expect during an intensifying warm phase event, pulling the jet stream into a pattern that dumps moisture and cooler air into one region while starving another of both. Almost like the atmosphere is trying to balance its own books by taking from one column and adding to another. Out west, it's a similarly divided picture. The West Coast and the Southwest have the strongest warm signal in the country right now, and the Southwest monsoon is expected to run more active than normal, which is actually a bit of a double-edged sword. On one hand, more monsoon moisture means drought relief for a region that desperately needs it after years of below-average precipitation. On the other hand, when you get sudden bursts of heavy rain hitting ground that's been baked hard and dry for months, that's a recipe for dangerous flash flooding, the kind that can turn a dry wash into a wall of water in a matter of minutes, catching hikers and drivers off guard in terrain that looked completely harmless just hours earlier. Up in Canada, it's been an exceptionally active summer already, with Ottawa recording its wettest month on record in July, and Edmonton logging its wettest summer ever measured. As we move deeper into August, forecasters are expecting above-seasonal heat to shift westward, building across the prairies and into British Columbia, and that combination of dry heat on top of a landscape already stressed by earlier flooding and fire activity is going to keep wildfire risk elevated in several regions through the rest of the month, particularly in areas where downed and dried vegetation from the wet spring now becomes fuel once the heat moves back in. Now here's the part that I think doesn't get talked about enough, and it's the part that actually matters most for planning ahead. All of this current summer disruption is really just the appetizer. El Niño's strongest and most reliable impacts on North America don't actually show up in summer at all. They show up in winter. The reason for that comes back to the mechanism we talked about earlier. El Niño's influence on the jet stream is strongest when the temperature contrast between the tropics and the poles is at its most pronounced, and that contrast peaks during the northern hemisphere's cold season. So while summer gives us these regional heat and rain imbalances, winter is where El Niño really takes the wheel, and it does so by essentially hijacking the position of the jet stream itself, pushing it into a more southerly active track that behaves very differently from a typical winter pattern. Based on the current trajectory and drawing heavily on how previous Super El Niño winters have played out, forecasters are expecting a fairly classic but amplified version of the typical El Niño winter pattern. That generally means a warmer, drier signal across the northern tier of the country, from the Pacific Northwest through the northern Rockies and into the upper Midwest, and a wetter, stormier pattern locking in across the south. The southern jet stream tends to become the dominant storm track during strong El Niño winters, which usually means increased rainfall potential from California all the way across the Gulf Coast and up into the southeast. At the same time, because that southern storm track is so active, when cold air masses do manage to punch down from Canada and collide with all that Gulf moisture, you can end up with some genuinely significant winter storms and snow events, particularly across parts of the East Coast and Mid-Atlantic, even in a winter that's classified overall as warmer than average. That's actually one of the counterintuitive things people get wrong about El Niño winters. Warmer than average doesn't mean snow-free. In fact, some of the most memorable East Coast snowstorms in history happened during strong El Niño winters, because you get these sharp collisions between unusually active southern moisture and cold air intrusions, and that combination can produce explosive storm development, sometimes with very little warning as the system rapidly deepens off the coast. If you want a real-world comparison, 1997 into 1998 is again the reference point most forecasters keep coming back to. That winter brought catastrophic flooding to California, with hillsides that had burned in previous wildfire seasons giving way in mudslides once the rain arrived. It brought a historic ice storm across the Northeast and into Canada that left millions without power for weeks, coating entire regions in inches of ice that snapped power lines and toppled trees on a scale that utility crews had never dealt with before. And it produced one of the mildest winters on record across much of the northern United States, with some areas barely seeing sustained snow cover for weeks at a time. If this current event tracks anywhere close to that intensity, and right now the model guidance suggests it might even exceed it, we could be looking at a winter that swings hard between extremes depending on where you live. Mild and dry in the north, wet and occasionally violent in the south, with the potential for a handful of genuinely historic individual storm events layered on top of that overall pattern. Now let's zoom out from North America, because this is a global event, and some of the impacts happening on the other side of the planet right now are honestly more severe than anything we're dealing with domestically. In the Western Pacific, particularly around Indonesia and Australia, El Niño typically flips the usual rainfall pattern into reverse. Remember that Walker circulation we talked about earlier. Under normal conditions, all that warm water and rising moist air sits over the Western Pacific, which is what feeds consistent rainfall across Indonesia and northern Australia. When El Niño weakens the trade winds and pulls that warm water back toward the central and eastern Pacific, it essentially starves the Western Pacific of the moisture it normally relies on. That translates directly into drought conditions across Indonesia and Australia, and during strong events, that drought can become severe enough to dramatically elevate wildfire risk across both regions. Australia in particular has a well-documented history of its worst bushfire seasons, lining up with strong El Niño years, because dry vegetation combined with reduced rainfall creates exactly the conditions fire needs to spread fast and burn hot. And Indonesia sees similar risk with peatland fires that can smolder for weeks and blanket entire regions of Southeast Asia in smoke haze. Meanwhile, over in South Asia, there's a different kind of concern building, and this one has massive economic implications. El Niño years have historically correlated with weaker monsoon seasons across India, and the Indian monsoon isn't just a weather event, it's the backbone of agricultural output for one of the most populous regions on the planet. A disrupted or below average monsoon can mean reduced yields for staple crops like rice, wheat, and sugarcane. And when you're talking about a country with well over 1 billion people relying on that harvest, even a modest percentage shortfall in rainfall can ripple through food prices, farming livelihoods, and regional economic stability. On the flip side, South America tells a very different story because, remember, El Niño pushes warm water toward the eastern Pacific, right up against the coast of Peru and Ecuador. That warm water disrupts the cold upwelling those fishing economies depend on, and it also tends to bring unusually heavy rainfall and flooding to coastal Peru and parts of Ecuador, a pattern so historically consistent that the entire phenomenon actually gets its name from South American fishermen, since El Niño translates to the little boy, a reference to the Christ child, because the warm water and disrupted fishing conditions traditionally showed up around Christmas time. There's also a piece of this that touches parts of southern Africa and East Africa, where El Niño years have historically been associated with drier conditions in the south, affecting agricultural regions across countries like Zambia, Zimbabwe, and South Africa, while sometimes bringing wetter than normal conditions to parts of East Africa, occasionally trending toward flooding rather than drought in areas like Kenya and Somalia. So you end up with this almost seesaw effect playing out simultaneously across multiple continents, drought in one region, flooding in another, all connected back to the exact same shift happening in one stretch of the Pacific Ocean. And this is really the piece that connects all of this together into something bigger than just a weather story. Strong El Niño events have a documented history of pushing global food prices upward. When you simultaneously get drought stress in major agricultural regions across multiple continents, reduced yields in some of the world's largest grain, sugar, and palm oil producing zones, and increased volatility in commodity markets that trade on exactly these kinds of forecasts, you end up with inflationary pressure that shows up on grocery store shelves months later, long after most people have stopped paying attention to the ocean temperature story that actually caused it. Coffee, cocoa, sugar, and palm oil are particularly sensitive to these swings because production is so geographically concentrated in exactly the regions El Niño tends to hit hardest, which is part of why you'll sometimes see commodity traders reacting to a Niño 3. For temperature update almost as fast as they react to an actual crop report. This is also exactly why you'll notice energy traders, insurance companies, and agricultural commodity markets watching these ocean temperature updates almost as closely as meteorologists do. A Super El Niño isn't just a forecasting curiosity, it's a financial signal. Insurance and reinsurance companies use these outlooks to model expected claims from flooding, storm damage, and wildfire risk across different regions, adjusting premiums and reserve requirements months in advance based on exactly this kind of data. Energy companies use the winter temperature outlook to forecast heating and cooling demand months ahead of time, because a warmer than average winter across the northern half of the country can meaningfully reduce natural gas demand, while an unusually stormy, cold, snap-heavy pattern across the south can spike it unpredictably in the exact opposite direction. And getting that forecast wrong can cost energy companies enormous amounts of money in mismatched supply contracts. Commodity traders watch drought risk across Indonesia, Australia, India, and parts of South America because those regions are massive producers of everything from palm oil to coffee to wheat, and disrupted harvests move prices on global exchanges almost instantly, sometimes before the actual physical crop damage has even happened, purely on the strength of the forecast alone. So here's the connection that I think most people watching casual weather coverage are missing entirely. This isn't just a story about whether it's going to be hot or rainy in your specific city over the next few months. This is a story about a single measurable shift happening in one region of one ocean that is currently in the process of recalibrating rainfall, temperature, storm frequency, drought risk, fishing yields, wildfire potential, and by extension, food prices and energy demand across almost the entire planet simultaneously. That's the scale we're actually talking about here. And what makes this particular event worth paying closer attention to than a typical El Niño year is the speed at which it developed. Going from a modest half-a-degree warm anomaly to blowing past the 2-degree Super El Niño threshold in the span of just a few months is not the normal pace these events usually follow. Most El Niños build gradually over the better part of a year. This one has been accelerating in a way that even the scientists tracking it in real time have described as unusually fast. And when something moves that quickly through the climate system, it tends to produce sharper, more concentrated impacts rather than a slow, gentle transition that gives regions time to adjust. There's also an important honesty check we need to include here, because forecasting at this range always comes with some humility built in. The Climate Prediction Center themselves have been clear that even the strongest El Niño events on record don't produce their textbook impacts everywhere, every single time. Stronger events simply increase the odds and the intensity of those typical patterns showing up. They don't guarantee a carbon copy of 1997 or 2015. Other atmospheric players, things like the Madden-Julian Oscillation, the North Atlantic Oscillation, and the Arctic Oscillation, all still have a say in exactly how any given week or month plays out on top of the broader El Niño signal. And those shorter-term oscillations can occasionally push back against or amplify what El Niño is trying to do at any given moment. So while the big picture trends we've talked about today are backed by strong historical precedent and increasingly confident model agreement, the exact week-to-week and region-to-region details are still going to have some natural variability layered in, and nobody should treat a seasonal outlook with the same precision as a 5-day forecast. But when you step back and look at where the confidence actually is high, it's hard to ignore. Nearly every major forecasting agency, government and private, along with financial prediction markets, are now converging on the same outcome. A historically strong, possibly record-breaking El Niño, peaking sometime between late fall and early winter, followed by a winter pattern that swings between unusually mild and dry in the north and unusually wet, stormy, and occasionally extreme across the south. Layer on top of that, a quieter but still unpredictable Atlantic hurricane season, an active and dangerous wildfire risk building across Canada, Australia, and Indonesia, a weakened monsoon threatening food security across South Asia, disrupted fishing economies and flooding risk along the South American coast, and rippling effects into global commodity prices that most people won't even connect back to an ocean temperature anomaly until their grocery bill goes up. That's the full picture, and that's why this shift genuinely has the potential to touch almost everything, even for people who have never once thought about equatorial Pacific sea surface temperatures in their entire life. So what do you actually do with this information? If you're in a region flagged for above average heat and dryness this fall, that's worth factoring into anything involving water use, agriculture, or fire preparedness, and it's worth having those conversations with family or local officials earlier rather than later. If you're somewhere in the path of that active southern storm track heading into winter, it might be worth paying a little more attention to your home's flood and storm readiness earlier than usual this year, rather than waiting until the first big system is already on the radar and supplies are harder to find. And if you're someone who pays attention to food and energy costs, understanding that this kind of global climate shift is already in motion gives you a head start on why certain prices might start moving in the months ahead, well before it becomes the actual headline everyone else is reacting to after the fact. What do you guys think about all this? Do you think this Super El Niño ends up matching 1997, or do you think it goes even further than that? Let me know what you're already noticing where you live, because these patterns tend to show up differently depending on the region, and I'd love to hear what's happening on your end down in the comments below. If this kind of breakdown helped make sense of what's actually going on behind the headlines, go ahead and drop a like. It genuinely helps this kind of content reach more people who are trying to actually understand these shifts instead of just reacting to the next viral weather clip. And if you want to stay ahead of how this pattern develops over the next several months, make sure you're subscribed, because this is very much a story that's going to keep evolving fast. And there will be a lot more data coming in as we move deeper into fall, and this event either confirms or exceeds what current forecasts are suggesting. Feel free to share this with anyone you know who's asking why this year's weather has felt so unpredictable, because now you'll actually be able to explain the mechanism behind it instead of just saying the weather's been weird lately. Thanks so much for watching, and we'll keep tracking this one closely as it develops.